Hello guys. So in this video we will understand the concept of list and why do we actually use list. So consider this scenario where you are being asked to write a program to add three numbers. So you will very simply create three variables as I'm writing here, and then you're going to say finally the result is equals to a plus b plus c, so on, right? So this is very simple way to write the program, but consider if same thing is being asked and the number changes from adding three numbers to adding 10 numbers or adding 15 or 20 numbers. So in that case we cannot create 15 variables and so on like this. We cannot do this, right? So we have to find a proper and modular approach. So for that we use the concept of list. And how does the concept of list actually works? So the concept of list is very simple, okay? So what it does at the end, if you have any data, it is going and it is storing in the RAM, right? We know that very well. And in RAM there are trillions and trillions of memory cells. These memory cells in low level you can call them either group of registers, or you can tell them in the single unit a flip-flop, group of flip-flops, okay? So we have such multiple memory cells, right? Now once we create some data, if I say a is equals to 5, so it search for an empty space and creates like this memory location. But since I'm looking for large amount of data and I don't want to create multiple variable names there, then what happens is we use the concepts of list. So how in concepts of list it works is we give one single variable name. Say for example I'm giving a as the name for my list. Then I can store n number of values in this single variable name. I can store multiple values, so I can store 1 2 3 6 8 9 0, so on. I can store multiple values within the list. Then how does it get stored? So the first condition is when you're creating a list and you're storing multiple data within one list name, that is your variable name. So what happens is it search for continuous memory, okay? So in your RAM it searches for continuous memory locations, and if there are continuous memory location, then it places the data in that continuous form. So the data will be successive. It has to be in continuation. There is no breakage saying that there's one data here, another data somewhere in this corner, and some data somewhere in this corner. So mismatch like this. There is no mismatch in that way. It has to be continuous and successive, right? Now after that, how do we uniquely identify each of this, right? So they have addresses, as we have seen in concept of variable, every cell will have an address, but we cannot remember address, right? So in that case what happens, an indexing is being given. So consider this, it starts from index 0. So in any programming language you go, the index always starts from 0. So I have 0 1 2 3 4 5 and 6. That is, I have 7 elements in variable a or in list a, and these are the index. So if I say from a get me element in position 2, that is this position index 2, so it will return me data 3, right? So when I'll say from in a, right, from a get the element position from 5, so it will return me 9. Or if I say in a position go to position number 6 and then add data 10, so here the data overwrites to 10. So using this index you can create a list where you can add multiple data within a single variable name, and using this list you can access them. So this is the concepts of list, how it works. So let us look at example. If same program, if I write it in list, how it is going to be. So I will create a new list called as nums. And how do we create list, or what are the ways to represent? So basically we use a square bracket if you are going to assign a value, okay? Now I can give multiple datas in here. So this is a single list which has multiple data like this. So how it is getting stored? So I can quickly give you a representation of how it is getting stored. So given like this, you have multiple memory cells. So here I have variable called nums in which I'm storing like this value 1 4 5, then we have 7, then 8 5 and so on, and then we have 3 and then 2. So we are storing elements like this. So how does it store? With indexing. So there'll be 0, 1, 2, 3, 4, 5, 6 and 7. Okay, always index starts from 0. So if I say nums of 0, that is from nums, get me what is there in position 0. So you will get this 1. So let me show that example. So I will say here, from nums, get me what is there in position 0. So we use square brackets to get the positions. Okay, so if I run this, it returns me 1. The reason is, if you go back and see here what we drew, at position 1, 1 is being stored, right? Same way, if I say in nums, get me the element in the position 6, so it returns 3, because you can see in position 6 we have element 3. Now I can reassign value. I can say in position nums, position 1, reassign it to 99, that is 99. So now if I check complete nums, so it's a list of the new modified list. So you can see from position 1, that is 4, it is been reassigned to 99, and now I can have a complete list. So this is how it works, list in Python. So you can see the features where you can have multiple such elements that are stored under one single common name. So storing this sequence of elements is list, right? And here it's need not compulsory that you have to store homogeneous value, that is, it should be completely integer. It can even have heterogeneous value. So I can say new list is equals to, I can create a list with integers. I can even give any other strings. I can give strings. I can give some floating point values like this. I can give some complex number 5 plus 9, 5, something like this. So you can see now if I print new list, so you can see it can have heterogeneous values also. That is, this is of integer types. Then in same list I have string types. Then in same list I have float types. And in same list I have complex number types, right? So you can see that you can even store heterogeneous elements within this list. And also you can store a list within a list, which is known as a nested list. So let me give you an example for that also. So given nested list variable, so I'll create a nested list. So I'll say 1, 2, 3. Now in fourth position I will add another list called 5, 6, 7, and then fifth position, or within this I will create another list called as 8, 9 and 10. So now if I execute this nested list, if I run this nested list, so you see I have a list in which the fourth position is another list, and for that list I have another list inside. So we have this nested list. So how is this actually represented? Okay, so let us picturize that, how it is represented nested list. So here consider I have a list. Okay, now here I store 1, then I store 2, then I store 3. Then after 3 I have another list that is stored here. So what happens, this memory space, it cannot store 3 values. So what it will do, it will store address of new memory location of 3 values, that is 4, 5 and 6. And then this again after 6 we have, okay, now we have another list within this. So here it takes address of another list and we store the number 7, 8, 9 and so on, something like that, right? So as you can see here, this is how nested list works. And if I say this is a nested list variable, okay, so how does indexing works? Always starts from 0. Now this is a new list. So since this is a new list, again the index will start from 0. Again, as this is a new list, indexing starts from 0. So if I want this particular element here, so what will I say? From number list, go to position number 3. So in that case it will give this entire list. Within that list, get me another element from position 2. So you can access, you can give multiple address to get this data. So now if I give same thing, so I say nested list, and from that I'll say position number 3. It is going to return me entire list. In that, give me element at position number 2. So you see it is going to return one single number based on this, that is here 7. So this is how your nested list works and how do we access elements in nested list. Next, we have multiple methods with respect to list we can use in order to perform some operations like adding some data or removing some elements from the list. So let me create a new list I'll give the name new list and I'll add some data like 1, 2, 3, 4 and 5. Now consider you want to add some data to this existing list. Okay, so you can straight away use a keyword called as append. So we have this keyword, or you can say, sorry, method called as append, in which I can just say append 6. So what happens using method append is at the last it goes and appends the data. So now if I say new list, so you can see it goes at the last and appends a new data. Now the next case is, what if I want to insert it at some particular position? So there we will be using another method called as insert, right? So we'll have a method name called as insert, and here we will give two arguments. So we'll pass the position where I have to insert and data what I have to insert. So if I run this, so in this new list, if I print this new list now, so you can see at position number 1, that is, see, this is 0, this is 1. So at this position a new data gets added, that is 10, and other elements gets shifted. This is using append. Also, if you want to add multiple data, that is, you want to add another list to this list, so in that case you can use extend method. So you can say new list dot extend. So I can extend it, so I can here pass another new list. I can say here 890. So now if I print new list, so you can see I have extended 890. So if you want to add multiple data, you can use extend, and you can extend by adding multiple data also. So these are the cases and methods to add data. What about if I have to remove a data? So there are a couple of methods for that also. The first one is very simple, that is method pop, which pops element. So if I say pop, so see, the last element gets popped up, and also it returns the value, so you can store it in some variable if you want. So now if I print new list, so you can see the 0, that is that last element is been removed. Now you can use this pop method and also specify the position. So pop the position at element 0. So you see at element 0, at position 0, you have element 1 which is get new popped. So now if I check new list, so you see that is been popped. So you can use this pop method. But you might think, what are the case when if I don't know where is the element, but I know only the value. Say for example, I know that this list contains 10, but I don't know where is the position of 10. So in that case, you can use a method called as remove. So in this remove method, you can just pass the data you want to remove. So element I have to remove here is 10. So it goes and search for that elements and it removes that element. So you can use this also. You can use the del keyword also to remove an element in the specified position. So I'll say new list of position 0 delete. So it is going to delete that. So now I'll say new list. So you see it deletes from position 0. Also, this del keyword can be used to entirely delete the object. So it deletes the entire new list. So now if I go to run new list, so see I get this error because it deletes the entire list. There is no such list called new list. That's why it gives me an error saying new list is not defined. So these are some useful methods that we will use in list in order to add and remove data, and these are the concepts of list in Python.